Hey everyone, I'm Meteorologist Stefanie Lauber, and in this week's Science Snippet, we're going to talk about supercell thunderstorms and hail to kind of explain how the event we saw this past weekend, November 1st, compares to the climatology here in the coastal bend. How common is it to have the kind of destructive hail that many of our neighbors reported back on Saturday? So let's take a look at the radar, and you see three distinct storms here moving across the coastal bend. One near San Patricio County, one near Baffin Bay, and one that swipes right over Alice in Jim Wells County. So these aren't the usual kind of thunderstorms that we tend to see here across the coastal bend. These are supercell thunderstorms, and they have a different quality than the normal kind of thunderstorms we're used to. Hence, they're not very common here, and there is a reason for that. But when they do happen, oftentimes they do drop damaging hail. So let's talk about the ingredients that go into making a severe thunderstorm. We like to use the acronym SLIM because the ingredients are shear, lift, instability, and moisture. And we certainly had all of this. Now, there's one ingredient in particular that is really necessary to have a supercell thunderstorm, and it's this first one, shear. We can have shear, but that usually produces the kind of thunderstorms we see, which form in a line. To have supercell thunderstorms, you need quite a bit of shear. You need a lot of change in wind direction with height, so you get that twist in the atmosphere, rotation, and that is the kind of storm that will churn out the kind of damaging hail that we saw this past weekend. So let's talk about how hail is born. Now, in a thunderstorm, of course, rain, those are water droplets that come down, but up in the thunderstorm, once we get past the freezing level, which this weekend was around 12,000 feet, those raindrops freeze and then gravity brings them back down. But when they're small, strong updrafts, upgoing winds can pick them back up into the cloud where frozen raindrops form onto that frozen drop, and we get layers, kind of like an onion or maybe like an ogre. So once that process happens enough times where we have that sinking and rising, refreezing process, eventually that hailstone is going to grow large enough to outweigh that upgoing force of the updraft, and it will fall to the ground. But how big does a hailstone have to be in order for that to happen? Well, the kind of hailstones that were reported this past weekend were as large as tennis balls and baseballs. That's around 2.5 to almost 3 inches in size, but it's not the biggest hailstone that's ever been reported in the coastal bend. No, that was more like grapefruit size. We had a 5-inch hailstone reported in Jim Wells County back in 1968 with a thunderstorm that was a supercell. So it just goes to show hail can get pretty big here, even in South Texas. Once you have hail that big though, a quarter or larger, you're talking about severe levels, damaging hail that would normally trigger a severe thunderstorm warning. Again, like what we saw this past weekend. But to see hail that big is very rare here across the coastal bend and in general. So you might be wondering, in the process of making that hail, how strong do the updrafts that carry these stones up have to be? Well, when we're talking about hail that is the size of tennis balls and baseballs, those are updrafts with speeds around 75 to 80 miles per hour. So very strong winds before these hailstones eventually outrun the updraft and sink all the way to the ground. So the event we saw this weekend was pretty exceptional. If you want to learn more about it, you can read it in this week's Science Snippet.